So we're here in section 7.4, moving on to page 223. We're going to start talking about factoring the polynomial here. We talked in the first video about finding a greatest common factor. So we're only factoring by pulling out the greatest common factor of each term. You know how to do the distributive property, which if I had something like this, 3x times 2x minus 5, I would multiply into both terms and distribute. 3x times 2x, 3 times 2 is 6, x times x is x squared, 3x times negative 5 is negative 15. You already know how to distribute and end up here at the polynomial. But what we're going to talk about in this section is how do we go the other way. So this is distributing, going this way is factoring, and our goal is to find what is the biggest amount that we can put out in front. So all of these are going to end up with a set of parentheses. I have two terms here, so I'm going to need two terms inside my parentheses, and I'm going to need to figure out what's the greatest common factor of those two terms. So when you're looking at the variables, what is the most that you can pull out or divide out of each term? Well, there's two x's here, but only one here. So the most x's that we can divide out of each term is a single x. Then we need to be thinking about the greatest common factor of these two numbers. The first thing I want you to do is check to see if the smaller number is the greatest common factor. So with 6 and 3, does 3 divide 6? Well, I know 6 divided by 3 is 2, so 3 will be the greatest common factor. So 6 divided by 3 equals 2, so that tells me that 3 is my greatest common factor. So if I divide 3x out of each of these, 6 divided by 3 would be 2, and if I divide one of these two x's out, I would have 1 left. Bring my plus sign down. 3 divided by 3 is 1. X divided by x, also 1. So now I've factored out the greatest common factor. Same thing for, excuse me, number 14. We need the greatest common factor and two terms inside the parentheses. So first of all, does 20 get divided by 4? So 20 divided by 4 is 5. So that means 4 is a part of my greatest common factor. And then how many y's can I divide out? Well, I have 4 here and 3 here, so I can factor out 3 y's from each term. Then I would have 1 y left out of 4. 4 divided by 4 is 1 as well. And then bring my minus sign down. 20 divided by 4 is 5. And I took all 3 y's out of that first term. So now I've factored out the greatest common factor. That's all you have to do to find the greatest common factor. What if we have one like 16? We tried in the first video to find the greatest common factor of 2 and 7. Turns out the greatest common factor of those two numbers was just 1. That's the only factor that they have in common. So I can divide a 1 out of this binomial. What else? Well, they both have z in common, so I can take 6 z's out of each term because there's more than 6 z's in the first term. So 7 divided by 1 is 7. Z to the 7th, if I take 6 of those out, that leaves 1 left. Then 2 divided by 1 is 2. I had 6 z's here. I took all 6 out, so there's no z's left. The other piece of this is putting them both together. So we're going to want to factor, and then we will solve from our factored form. So let's take a look at number 19. So this is really 1k. What's the biggest number that divides 1 and 6? Well, it's 1, but they both have k in common. The most I can take is 1, so I have 1k. 6 divided by 1 is 6. Had 2k's, took 1 out, so 6k. 1 divided by 1, and k divided by k is 1. So there's my factored form. Now I have two factors, just like in the first section. Now I can set them each equal to 0 by the zero product property. So 1k equals 0, and 6k plus 1 equals 0. So I don't have to do anything to solve there. That's one of my two solutions. And here I'd have to subtract the 1 from both sides, then divide by 6. So k equals negative 1/6, and that's my other answer there. When I look at number 20, so 49 divided by 35 is not going to be a whole number, so I need to know what are some common factors, I'm not going to do 21, of number 20. So 35 is 7 times 5. 49 is 7 times 7. So what do they have in common? They both have a 7. So 7 is my greatest common factor. And I have one n here and two n's here. So the most I can divide out is 1n. What's left here? Well, 35 divided by 7 is 5. And there's no n's left. Then I have 49 divided by 7 is 7, and I had two n's, I took one out, so 5 minus 7n equals 0. Now, again, I've got two factors, so I would want to do the split them up, set them both equal to 0 step. I'm going to bring this one up here to solve, actually. So if I divide by 7, 0 divided by 7 gives me 0 for one of my solutions. And the other one, I would subtract 5 from both sides. Make sure that you bring the negative down with the 7. And then I would divide by negative 7 on both sides to isolate n. Negative divided by negative, so positive 5 over 7. There's my other solution. If you see a question like 22, 23, or 24, this last step, the zero product property, only works if we're equal to 0. So the first thing we have to do is move everything to one side. So I'm going to subtract 21p to the left side. That way I have 7p to the second minus 21p equals 0. And then I can go ahead and solve this in the same way. I can check to see, can 21 be divided by 7? It can. 21 divided by 7 is 3, so 3 is my greatest common factor. I can take a maximum of 1p from each term. So, sorry. 7 is my greatest common factor, and I have 3 left from 21 when I divide that out. 7 divided by 7 is 1. I have a 1p left, no p's left in the second term, and again, split my two factors up. 7p equals 0, which means that p equals 0. And here, p minus 3 equals 0, so add the 3, and p equals 3. There's my two solutions. All right, thanks.